going to do the second section, which is all about volcanoes. And if you haven't heard me say it yet, it's a big section. Yeah, they're long notes today. Usually most textbooks cover this in a chapter, and this is covered in a section, so clearly it's going to be a lot of information. Looking at those tectonic plate boundaries, and if you look at this map here, I see all of those red dots, and you should notice a correlation. Wow, all those red dots are along plate boundaries. So yeah, it's just like earthquakes and how we saw a correlation between earthquakes and plate boundaries. We see the same thing for volcanoes. If you're having an area where it's opening up in those tectonic plates, or you're having one of the tectonic plates being melted, then clearly you're going to set up a scenario for volcanoes. So yeah, there's the world's most active volcanoes on Earth, all of those red dots, and you can see a lot of them are along plate boundaries. Not all of them. If you look at Hawaii, very popularly known obviously to us, is not along a plate boundaries. Most of them are, but not all of them. Can't talk about volcanoes without talking about the Ring of Fire. Also very famous Johnny Cash song, but in this case, it is the active volcano zone that surrounds the Pacific Plate. Most active volcanoes on Earth actually surround the Pacific Plate, tectonic plate. So half of the active surface volcanoes on Earth are in this area. So you can see why it gets that name, the Ring of Fire. All right, some vocab terms. Volcano is anywhere on Earth where lava is released. So a site where lava is released is called a volcano. Once the magma reaches Earth's surface, we call it lava. So essentially, once it hits the air, we call it lava. And then when it's beneath Earth's surface, we call it magma. So really, they're the same thing. The only difference is where they're found at. So lava is above Earth's surface. Magma is below Earth's surface. And they kind of start you off with probably one of the most famous volcanoes in the United States, and that is Mount St. Helens, as you can see in the little red dot there, which is located in the state of Washington. So Mount St. Helens, a volcano, a place where lava is released. You can see in this picture here, lava is not coming out of it. So it's not like you see in the movies where you always have this idea that, you know, magma is spouting from the volcano. Yeah, that is some volcanoes, but it's not all volcanoes. Every volcano kind of has these basic parts to them. You have a magma chamber that is beneath Earth's surface, full of magma, obviously. In the middle there, we have what is called the conduit, or it's also sometimes called the central vent. And then you're going to have magma be released from the central vent, but you also have side vents coming out of the volcano as well. So really pretty much that's every volcano, that's its parts. Right, so what erupts from a volcano? So we have different, when that magma comes up and that lava reaches Earth's surface, we have different types of lava. So it's going to depend upon what is the composition of that lava, and it's going to depend upon what should I say? What is the conditions at which it hardens? So we have blocky lava. This stuff is called pahoehoe. It looks kind of like wax when it's been melted. You should also start to notice here some Hawaiian similarities. This is a'a. Yes, that's a weird word. This last one here is called pillow lava, and it should look to you like it's underwater, which it is. When magma comes up from underwater and it hardens quite quickly because that water is cool, you actually get pillow lava. Fun fact for our area, actually behind the Gilbert High School, there's a really big pillow lava formation behind the football field there, which is cool because obviously at one point in time in Gilbert, Minnesota, there was actually magma being released underwater if we see pillow lava here on Earth's surface. All right, so life of a volcano. If a volcano has erupted recently or is in the process of erupting, we call it active, and we're going to assume that it's going to erupt again. If a volcano may not be active, but we feel like it has the good chance to possibly erupt, maybe it's erupted within the last 200, 300 years, we call those volcanoes dormant volcanoes, so they're not active now. If we feel like a volcano is probably never going to erupt again, we will then call that volcano extinct. So we actually classify volcanoes based on if we think they are going to erupt or not in the near future. So where does this magma come from? We can have magma form a couple of different ways. First of all, you're melting rock. That's what magma is, right? It's melted rock. So there's two ways you're going to melt rock. You're either going to reduce pressure. So when you release that pressure, those molecules have the ability to move around. When they move around, now they can turn into liquid form. So if the Earth in some way, shape, or form releases that pressure, you are going to get magma formed. You can also change the composition of the magma. So If water gets mixed in with the rock somehow, that can change the composition enough that it's going to melt it. And then obviously temperature, I didn't mention that one yet, but obviously we know if you increase temperature, you're going to also get rock forming that way. So don't always think of it just as it's getting hot, I guess I should say. Types of magma. So we have different types of volcanoes on Earth. We have these volcanoes that will explode violently. We have other volcanoes that don't explode violently. And why is that? It's all about the magma. So the types of magma will determine what type of volcanic eruption you have. So an important property of magma is actually how much silica it has. Silica, SiO2, remember, is what makes up the mineral quartz. If magma does not have a lot of silica in it, it's actually pretty runny. If magma has a lot of silica in it, silica makes it thick and goopy. So that thick, goopy, sticky magma, think of that coming up through the volcano, plugging up the vents. If you have that thick, sticky magma, it's going to make that volcano more likely to have an explosive eruption. If it's runny, it's just going to kind of come out at a slow pace. Another property is how much gas is found in the magma. If the magma has a high gas content, it creates fizzy lava. So it's almost like, imagine a pop, you shake that pop up with all of the gas inside of it, you open it, poof, the lid explodes. Same thing happens with magma. If it has a high gas content, it makes it fizzy and it's more likely to have these explosive eruptions. And your textbook has this little table in there for you, just kind of showing the different types of eruptions we can have. So for example, if a volcano has magma with low gas, low silica, you're not going to get an exciting eruption, quiet eruption, lava flows easily. Low gas content, high silica, so it's goopy, but it's got a low gas content, quiet eruption, but you're still going to have thick, sticky magma. High gas, low silica, runny magma, you're going to maybe get these cool features called fire fountains, but the lava is going to flow easily because it has that low silica content. Finally, if you're looking for the exciting ones that you see on the movies, the top's going to blow off the volcano. You're going to have pyroclastic material everywhere. That's going to be the last one in purple there. High gas, high silica content. You have thick, sticky magma. You're going to definitely get an explosive eruption from that. So our different types of volcanoes come from different types of magma. Different types of volcanoes come from different types of magma. So depending upon silica content and depending upon gas content is how we get these different types of volcanoes. So we have three major types of volcanoes on Earth. Our first ones are called shield volcanoes. They're called shield volcanoes because they look like a warrior's shield that has been placed flat on the ground. So as you can see in the picture here, very gently sloping sides. Most of us, if we looked at that picture, would be like, oh, there's a cool hill. You're not looking at that and saying that looks like a volcano. These volcanoes have really low silica magma. They're just built from repeated non-explosive eruptions. So just imagine this runny lava that just continues to ooze out over the top. It slowly goes down the sides, and that's the reason why you get these shield volcanoes. Most of these are found in Hawaii. Here's another picture of Mauna Loa. It's actually the world's largest structure when you look at square footage of it. But that is a shield volcano. Once again, hey, doesn't look like a volcano, actually a volcano. Composite volcanoes, when we look at the word composite, composite means, coming from different parts, right? So a composite volcano, these are actually the ones when we look at them, you're like, that's a volcano. So composite volcanoes, these guys have steep sides, but they also have a broad base to them. They're made from thick, high silica magma, and they're actually also made from repeated non-explosive and explosive eruptions. So it's two different types of eruptions going back and forth. Explosive, non-explosive, explosive, non-explosive. And that's where the word composite comes from, coming from the two different parts. So I'll show you some pictures here of these guys. Oh, here's just a side picture showing us. Mount Rainier in Washington. So now you start to look at these and you're like, oh yeah, that's a volcano. Mount Hood in Oregon. Steep sides, broad base. Mount Shasta, found in California. And then finally, here's another one, Mount Fuji, found in Japan. So all of those are composite volcanoes built from repeated explosive, non-explosive eruptions. Other famous volcano, which I mentioned earlier, composite volcano, is Mount St. Helens in Washington. It erupted violently on May 18th of 1980. It blasted away a whole side of the mountain, as you can see in the picture here, flattened 600 square kilometers of forest. It killed 57 people, and you can quite drastically see the difference between Mount St. Helens before and after. Before, its elevation was 9,677 feet, and after it exploded on May 18th, it was only 8,364 feet. Couple other cool pictures here. This is just another one showing you that drastic difference in what it looked like afterwards. And I've always thought this picture was cool. I don't know if you notice it, but there's two people standing kind of in the lower right-hand corner here, just to give you an idea of how powerful that explosion was. Imagine the force that must have come from that volcano to literally level completely on their side all of those trees. You see nothing left, no remnants left of anything. It looks like essentially a nuclear bomb went off, and that's really how much power is coming out of these volcanoes. Last type of volcano is a cinder cone volcano. Cinder and ashes. Cinder cone volcanoes are made from only pyroclastic material, so you're just having these repeat moderate eruptions over and over and over again. They're usually not that large. They usually erupt for small periods of time. They're also usually in groups of them, but because they're just made of this pyroclastic material, think of this like volcanic ash, they don't last long. So think about wind, rain coming along, it's going to be easily carried away. Just to show you a couple of pictures of these. There's a cinder cone. And here's another one. I believe this one was in Nicaragua. So smaller cinder cone, much smaller, and essentially just made of that pyroclastic material. Your book then talks about some features that we see on Earth's surface that are from volcanoes. This first one here is a caldera. So after that volcano erupts, you can sometimes get a depression that is formed in the ground, and that's a caldera. On the right-hand side there, you can see that is what happens when they fill with water, which often happens. Crater Lake in Oregon is a famous caldera lake. Sometimes you can get some magma that will come back up after it erupts. We call those resurgent domes. You can see in the middle here, this one is from Alaska, so kind of in the base of the caldera floor, you can see that ash coming back up. If water fills the caldera or magma doesn't drain completely, you can also sometimes get, if it's still active and it's still releasing lava, you can get a lava lake that forms. These are really cool features. I like the picture on the right-hand side because it shows you really where this comes from. So after that volcano erupts, and let's say it's gone into dormancy, and now you have erosion over millions and millions of years taking away that topsoil, what you're going to get left with is that igneous rock on the bottom, that volcanic neck, and that's what you see. So if you've ever seen shiprock before in New Mexico, or Devil's Tower in Wyoming, that's really all they are. They're what we call volcanic necks. So they're the remnants of an ancient volcano. And just imagine, if you've seen these things in person, just how large they actually are, how large that volcano has to have been to leave those giant geological features. In explosive eruptions, so when volcanoes erupt explosively, that material that comes out of it, if you get a large amount of it, we call that the pyroclastic flow, which, as you saw in that Mount St. Helens picture, can be extremely destructive to anything that's in the area. If that volcanic pyroclastic flow mixes with water, that is called a lahar, and it will form a mud flow. So mud flows formed from explosive eruptions are lahars. You can also imagine how devastating they are. Water itself is devastating, and now add in the fact that it's mixed with mud. So now you have all of this mud moving over geographical landscape. You can see just how devastating that would actually be. A granite dome, these are kind of cool. So you can see they're showing you a picture here of how a granite dome forms. So let's say we have one plate being subducted under another, and you get magma that just sort of pops up a little bit. Over time, the erosion wearing away the material on the top, and then you can be left with granite domes up on the surface. It's much harder to wear away that igneous rock if there's sedimentary rock surrounding it. There's just kind of a picture showing that. If you've ever been out to North Dakota, South Dakota, I'm sure you've seen granite domes out there. They're really kind of cool features. Volcanic islands that are away from plate boundaries. So this is volcanoes that we will see in the middle of a plate. So volcanic islands can form when mantle plumes bring material from deep within the ocean or deep under the ocean here. So you can see the picture on the side here. For whatever reason, we have a weak spot in the Earth's crust, so magma is making its way up and then coming to Earth's surface and forming volcanoes. And we call these things hot spots. So hot spots are an active mantle plume. They are not found near a plate boundary. And this is what Hawaii is. So you can see this sort of cross-section picture of Hawaii here. Hawaii is sitting on top of a hot spot, so it's sitting on top of a mantle plume. But we also know from what we just learned about in the previous chapters that that plate is moving. So because that tectonic plate is moving and the mantle plume is going to stay in the same spot, it's actually going to continue to produce new land. And so then what we get is these chain of islands. We actually have a new island that's forming. So here's Hawaii. So that's the youngest island, but there is one that's being formed right now that's underwater. It just hasn't popped up yet. Lohi, I believe is how you say that one. That's going to be the new island of Hawaii. I like these pictures. I put them in here because it's just kind of showing you too. There's that hot spot staying in the same location, but the plate is moving. So oldest one is going to be the island that's farthest away from the mantle plume, Kauai. So if you look at the picture down here, Kauai 3.8 to 5.6 million years, whereas Hawaii is relatively young compared to that, only 0.8 million years old. So the farther you get away from Hawaii, the older the islands are. They used to be over that mantle plume, but because the tectonic plate is moving, they get moved along with it. So volcanoes' effects on Earth, just to talk about a couple of things. When volcanoes erupt and they emit a lot of ash into the air, they have the ability to block out sunlight. As we saw in that picture, they can, and in this picture, they blow down trees and buildings, can dam up river valleys. It can also smother crops. That's something that has the potential to kill a vast amount of people afterwards, is that killing of the food source afterwards. They can actually drop the temperature on Earth. So volcanoes have shown to literally drop the temperature on Earth because of all of the ash in the air blocking out sunlight. Just to go through a few famous volcanoes here, Mount Kilauea in Hawaii, it is what is known as the world's most active volcano. It's been erupting for centuries, but not explosively. I tried to pull up a picture here, just showing you guys all of the volcanoes that you see on Hawaii. So this one right here is Mount Kilauea, as you can see on there. And there's the shield volcano that we talked about earlier, Mauna Loa. Mount Pinatubo in 1991 erupted violently, but good for us. We kind of knew it was going to happen, so they had the ability to evacuate a vast amount of people, so the loss of life was considerably less. If they wouldn't have known, volcanoes do things before they erupt, and if we know that they're active, we have scientists that are monitoring them to sort of pay attention to what's going to happen. They'll change their gases that they're being emitted from. They will also rumble, and in that rumbling, if we have seismic stations around the area, they can actually pick up that rumbling. And then we also have satellites that can pick up temperature differences from space. So as that magma starts to reach near the surface of the volcano, it'll actually appear warmer from a satellite that's picking up thermal images. So all of these things will clue these geologists into the fact that, hey, this is probably going to erupt. Maybe we need to evacuate. But you can just look at the ash there on the picture there, how much ash was emitted from that. Indonesia is known as the land of volcanoes. It has more active volcanoes here than anywhere else on Earth in this small area. 130 active volcanoes in this one little spot here. Mirapai is considered the most dangerous volcano on Earth. It has erupted violently 68 times since 1548, which is a lot. That is a lot of explosive eruptions. Tambora volcano is on record for having the largest eruption. It's also found in Indonesia. In 1815, it had the largest volcanic eruption that we had seen in the last 200 years. The eruption and resulting tsunamis killed around 10,000 people just initially, and then they estimated more than 80,000 people died after because of the loss of food, because of the crops that it killed afterwards. All right, a lot of stuff for volcanoes. If I went too fast on anything, and I was trying to get through here fast so that this video wasn't the longest possible, you guys can pause it, you can go back. But yeah, lots of great information about volcanoes.